We looked at interpreting endpoints used in observational studies. We determined the type and strength of correlation between two variables and interpreted the results of regression analysis, and we described the propensity score matching technique. Now, given an observational study, evaluate its internal validity, which is the course learning outcome number 5 on the course syllabus. In observational study, we want to make sure that the patients are similar for prognostic factors that are known to be associated with the outcome. Because observational studies cannot be randomized, it is important to make sure that the study is adjust for any of these biases. However, the investigators can only adjust for risk factors that are known and measured. Residual confounding refers to important prognostic factors that the investigators do not know about or have not measured. And residual confounding is something that we can't really do anything about. It's a limitation of observational studies. Another bias that can emerge in cohort studies is detection bias, which is the tendency to look more carefully for an outcome in one of the comparison groups. This detection bias, which is also known as surveillance bias, can be reduced by selecting comparator group patients that are actually similar in likelihood of screening or testing, or by selecting outcomes that are likely to be diagnosed equally in both groups, or by adjusting for the surveillance rate in the analysis. Another bias that can emerge in cohort studies is attrition bias, which is basically when we have patients lost to follow-up. This can introduce bias because the patients who are lost may have different outcomes from those patients who are still in the assessment, and different groups may lose patients at different rates, so the groups will no longer be equal. Case control studies are susceptible to unmeasured confounding, as well as recall bias and interviewer bias. Especially since we're dealing with controls in a case control study. So control are the patients who did not have the outcome. So, when we have these patients in the study, it's a matter of their memory. So when we ask them questions, it's more likely for people who actually have the disease to remember things that can contribute to it, whereas people who don't really have the disease are unlikely to remember things because things aren't as eventful for those patients as opposed to patients who actually have the disease. And the person who's actually interviewing the patient can also introduce some bias. Someone who's interviewing someone who has the disease may ask more questions as opposed to interviewing someone who's otherwise healthy. This table summarizes some of the techniques that are used to minimize the risk of bias, and it compares the clinical trials to observational studies. So some of the techniques that we can use to reduce bias.